Let's be precise about what actually happened here, because the real sequence of events is stranger and more interesting than a single simple crash. SpaceX itself doesn't currently operate its own lunar lander. What actually happened involves one SpaceX rocket, one launch back in January of 2025, and two separate unrelated failures that played out more than a year apart. One, a lander's final, doomed descent to the lunar surface, and the other, a rocket stage that was supposed to burn up harmlessly, but instead spent over a year drifting closer and closer to the moon before finally slamming into it just days ago. Both stories start on the exact same launch pad, on the exact same morning. On January 15th, 2025, a SpaceX Falcon 9 rocket lifted off from Cape Canaveral, Florida, carrying two separate lunar landers on a single shared ride, a cost-saving arrangement increasingly common in the commercial space industry. One of those landers belonged to Firefly Aerospace, an American company, carrying their Blue Ghost Mission 1 spacecraft. The other belonged to Ispace, a Japanese company, carrying their second lunar lander, named Resilience. Both spacecraft rode together on the same rocket for the first stage of their journey, before eventually separating and following their own distinct paths toward the moon. Firefly's Blue Ghost took the more direct route, and on March 2, 2025, successfully touched down near a volcanic feature called Mons Latrelle, becoming, at the time, the only fully successful commercial lunar landing achieved by any private company. Resilience took a different, slower, more fuel-efficient trajectory, one that required over 4 months just to reach the moon, finally entering lunar orbit on May 6th, and spending the following weeks carefully adjusting into a stable, circular 100-kilometer orbit, setting up for its own landing attempt. That attempt came on June 5th, 2025, and it was, for Ispace, an agonizingly familiar kind of failure. This was already the company's second attempt at a soft lunar landing, after its first lander, Hakuto R Mission 1, had crashed back in April of 2023 due to a software error that caused its computer to misjudge its own altitude. For Resilience, the landing sequence began with a roughly 10-minute engine burn, one of the first critical steps in the final descent process, guiding the spacecraft down toward a target site in Mare Frigoris, a vast, ancient basaltic plain in the moon's northern hemisphere, poetically named the Sea of Cold. Everything appeared to proceed normally as the spacecraft descended, using a series of carefully timed thruster burns to slow itself and steer toward its intended touchdown point. Then, when Resilience was still roughly 192 meters above the lunar surface, something went wrong. The spacecraft's laser rangefinder, the instrument specifically responsible for precisely measuring the exact distance remaining to the surface below, so the lander's computer could calculate exactly how much it still needed to decelerate, failed to deliver reliable, timely data. Telemetry beamed back from Resilience. In its final moments, showed the spacecraft was descending at approximately 138 feet per second, roughly 187 kilometers per hour, dramatically faster than the safe landing velocity any lunar touchdown requires. 5 seconds after that alarming reading came through, contact with Resilience was lost entirely. Engineers at Ispace's Mission Control Center in Tokyo spent the following hours trying to re-establish communication, but the spacecraft never responded again. The company's own officials, reviewing the available telemetry, concluded that Resilience had almost certainly performed what they described plainly as a hard landing, a controlled way of saying the spacecraft had slammed into the lunar surface far too fast to survive. Roughly 2 weeks later, NASA's Lunar Reconnaissance Orbiter, quietly circling the moon and photographing its surface in extraordinary detail, captured images of the actual crash site, revealing a dark smudge on the lunar surface surrounded by a faint, bright halo, the unmistakable signature of a spacecraft impact kicking up a spray of lunar regolith across the ground around it. Later, more detailed analysis pinpointed the impact crater precisely, roughly 16 meters across, located about 282 meters south and 236 meters east of where Resilience had originally been aiming to land. When Ispace's engineers finished their formal investigation later that same month, they confirmed the specific cause, a hardware problem within the laser rangefinder itself. The instrument had been designed to begin providing reliable altitude readings once the spacecraft was still roughly 3 kilometers above the surface, giving its onboard computer plenty of time to properly calculate and execute the final landing burn. Instead, that first valid altitude reading didn't come through until Resilience was already less than 900 meters above the ground, leaving the spacecraft's guidance system with far too little time and far too little remaining altitude to correct its speed before impact. Everything else on board, its software, its propulsion system, its power supply, had functioned exactly as intended the entire time. The single point of failure was one specific sensor, arriving with its critical data dangerously late. That would have been the complete story on its own, a genuine, well-documented lunar lander crash, the second such loss for Ispace in just 2 years, but the story wasn't actually finished, because that same Falcon 9 rocket that had carried both Resilience and Blue Ghost off the launch pad back in January of 2025 had a second stage, the upper portion of the rocket, responsible for delivering both spacecraft to their correct trajectories before falling away. Under ordinary circumstances, a rocket's spent upper stage on a mission like this either burns up re-entering Earth's atmosphere or settles into a highly elliptical orbit around Earth that eventually decays and brings it back down naturally over time. This particular stage did neither. For reasons that remain genuinely unclear even now, this specific Falcon 9 upper stage managed to avoid re-entering Earth's atmosphere during its closest approaches, instead settling into an unusual, persistent orbit that kept bringing it closer and closer to the Moon with each pass. Astronomers tracking objects in SpaceX Lunar space, the region between Earth and the Moon, eventually noticed the pattern. And on April 29, 2026, astronomer Bill Gray, who specializes in tracking exactly this kind of orbital debris, calculated and publicly predicted the precise date and time this drifting rocket stage would finally collide with the Moon. That collision happened almost exactly on schedule, in the early morning hours of Wednesday, August 5th, 2026. The 4-ton rocket stage struck the lunar surface at more than 5,000 miles per hour, and this time, astronomers on Earth were actually ready and watching for it. The European Southern Observatory's very large telescope, based at the Paranal Observatory in Chile, successfully detected the impact directly, picking up distinct spectral signatures of sodium and lithium gas glowing briefly in the resulting impact plume. Sodium believed to have originated from vaporized lunar soil kicked up by the collision itself, and lithium likely coming from materials within the rocket stage's own structure. Dr. Barbara Ferreira, a media relations manager for the observatory, confirmed those specific readings lasted somewhere between 5 and 10 minutes following the moment of impact, a brief but clearly measurable signature of genuine real-time cosmic violence unfolding right on our nearest celestial neighbor. Just 2 days later, on August 7th, 2026, South Korea's own lunar orbiter became one of the first spacecraft to actually photograph the resulting aftermath, capturing satellite imagery of a freshly formed crater at the impact site, one that scientists had predicted in advance would measure roughly 60 feet across and about 12 feet deep, complete with a visible plume of scattered lunar dust and rock thrown outward across the surrounding terrain. So, to be completely accurate about what all of this actually represents, a Falcon 9 second stage, essentially an inert, uncontrolled piece of space hardware with no crew, no active mission, and no scientific instruments on board, joined a growing list of human-made objects, alongside various other rocket bodies and defunct spacecraft over the decades, that have ended up permanently embedded in the lunar surface, sometimes by design, and in this specific case, entirely by accident, the unplanned byproduct of an orbital mechanics quirk nobody fully anticipated when the mission first launched back in January of 2025. What makes this pair of events genuinely worth understanding together is what they reveal about two very different kinds of risk in modern spaceflight. Resilience's crash was a story about precision, about how even a single malfunctioning sensor providing critical data mere seconds too late during an unforgiving, fully automated descent sequence can be enough to doom an entire multi-hundred-million-dollar mission in the final few hundred meters of a journey that had otherwise gone almost flawlessly for months. The rocket stage's impact, by contrast, was a story about neglect, about how a piece of hardware nobody was actively monitoring anymore, discarded and presumed harmless, can quietly persist for over a year, drifting through space along a trajectory nobody had bothered to fully track, until it finally, almost inevitably, collided with the one large object it kept passing closer and closer to time after time. Both events trace back to the exact same rocket, lifting off from the exact same launch pad, on the exact same January morning in 2025. One failure played out in a matter of seconds, watched live by an anxious mission control team desperately waiting for a signal that never came. The other played out across more than a year of quiet, unnoticed drift, before finally ending in a flash of sodium and lithium light captured by a telescope in Chile and photographed from orbit by a spacecraft belonging to an entirely different country's space program. Two very different kinds of final moments, separated by 14 months, but both, in their own way, part of the exact same story that began the instant that Falcon 9 rocket cleared the tower back in January of 2025. If stories like this, the ones where a single mission quietly unravels into two separate, genuinely fascinating chapters over the course of more than a year, are what you come here for, stay close, because there's more still unfolding, one launch and one long, quiet drift through space at a time.